Welcome, Solmaz.
Thank you.
Very excited to have you here tonight. Thanks for joining us. You are the VP of Data Science and Engineering at Shopify.
Yes. Yeah.
And maybe let's start with a level set on Shopify, what it is, what it has become over the years.
For sure. So Shopify is a commerce platform helping entrepreneurs of every size, from small, medium size to really large merchants, set up, sell online, be wherever their buyers are. And last reported number sort of is that we are over 800,000 merchants in over 175 countries. So we have expanded rapidly. We were founded in 2009, so we've grown quite fast, and we went public in 2015. We were part of FirstMark's family in the beginning, so. Yeah.
Yes, we are incredibly proud to have been part of that journey, and have done a very small part to help. But what an incredible story, right? I mean, the idea of starting the company at the time where it was geographically, and to think that it's now a $30 billion market cap company is just incredible.
Oh, it's also been amazing to be inside the company. When I joined, we were 300 people, and now we are over 5,000. So it's been massive growth, really, over the years.
With an office in New York now, right? So you said so Ottawa. That may or may not be public. Is that public?
Sorry?
You have an office in New York now.
Yes. Now, as of a couple of weeks ago, we welcomed the Handshake team to Shopify. So we're going to have a R&D here, but we are headquartered in Ottawa, in Canada. So we're close to Ada team. We have also offices in Toronto, Montreal, Waterloo, and Berlin now. Yeah.
Very good. So why don't we start with your journey? So you're born in Iran, I believe,
Yes.
to a professor, father, and mother. Is
Yes.
that correct? So tell us how did you end up in your current position?
I think as I was growing up, I think one of the luxuries I had was that my parents always gamified math and computer science. And one of my earliest interactions was that, actually, let me ask a question, because everyone was asking about modern technologies. So I'm going to ask how many people in the audience know what's a punch card? How many have ever seen it being used? Awesome. Okay, so my mom was doing this thing, and I was like, "Oh, are you doing craft? You're making holes in this cards?" And she said, "No, I'm actually telling a computer to do something." And as a 4-year-old, that was just the most fascinating thing. So I don't think I ever learned math or computer science to be good at it, but it was what it enabled us to do, and I think that's how I got started. And
then I think you did a master's in Sweden, if I read correctly, and then you worked at Sloan Kettering.
Yeah, so I did a master's in Sweden, where right after I finished my undergrad in computer science, I very quickly realized that I enjoy using computer science and what I'd learned in other domains. So I went into bioinformatics and I studied in Sweden. Then I did research with Sloan Kettering. So it was around 2005. Neural networks were not cool yet again. So everyone was like, "Oh my God, it's not 80s. Why are you using neural nets?" But we were using neural networks to predict the structure of a cell after multiple drugs have come in. And it's kind of fascinating, what took me 2 years, along with a team, to do. Right now, with the advances over the last few years in compute and in storage, you can do probably over a week. Mm-hmm. And that has been really fascinating. And then after that, I did another degree in Canada, in McGill, where we used genomic data for predicting outcome of breast cancer, so that at the time of diagnosis, we can give more personalized treatment to people.
Mm-hmm. And then you found your way into Shopify, which is actually, by the way, interesting for anyone that's a startup and trying to recruit top data scientists. You found your way to Shopify through a hackathon?
Yeah, so there was this hackathon called Random Hacks of Kindness. And basically, companies or people get together to solve problems for nonprofit companies where they don't have a large tech team. So I went to the Shopify office. They were holding the hackathon, and I started talking to people there. And they said, "Yeah, we are growing a data team, and They said, "Why don't you come in for a talk?" So I went in for a talk, which was the interview, and then I got an offer. So I never actually submitted a resume, and I think that's one of the strengths of Shopify in hiring, is that we don't go super conventional ways. We just try to get to know people, know about their experiences, and excite them about problems we are trying to solve.
Yeah, and a little bit to the point about at Sloan Kettering, neural networks were not hot yet. I think at some point you were a data scientist before data scientists became hot as well, and I heard this somewhere or read this somewhere as well.
I think so. 10 years ago, probably, 10, more than that. So bioinformatics became like a very hot topic because we were enabled to get access to this massive amount of biological data. So you can see all the genes that are expressed in a cell, which is like around 25,000, and then you can get copies of it. So you had this massive sets of data, and you had few samples. So we had to figure out a way to find patterns, to find something. So I think fields that had to work interdisciplinary were sort of first versions of data scientists. And I don't think it's limited to bioinformatics. Like once we figured out, it helped us a lot in hiring because we realized like social sciences also have to deal with a lot of messy data and make conclusions about it. And they have had methods and they've been really good in inference. So we've hired from that, astrophysics. So I think those are the fields that we're doing data science, maybe before it was a field on its own. And I hope as a community, we tap into those resources more and more because they came with a lot of experience also when they join.
Yeah. And even that term data scientist, like everybody talks about all the time, is actually very, very new. Like at one of the first events we had here, we had Jeff Hammerbacher and DJ Patel talk about how they came up with the term. But like it's sort of crazy to think that a few years ago that title just did not exist.
Yeah, and they came up with it. And also, I find what's also fascinating is that there isn't like a clear definition of it, right? Every day there's like a new Venn diagram of intersection of different skills. And it's interesting that the field is going through so much reinventing itself as time goes by.
So what does a team look like now at Shopify? What is a data science team in a company of that scale?
So when I joined, the data science team was 20 people. Right now, my team is over 200 people. So the approach we've taken through the years is that we are first and foremost a product company focused on our merchants. So the way we have also sort of formed our data science teams is this teams that are embedded in different business units or different product areas.
Interesting. So there's no central data science.
So we all report through the same structure to me, but because we care about the quality of the craft, and we also think data is an artifact that doesn't end in one product. Like a merchant lives through a spectrum of services, so we didn't want to have that disconnect. So we have a central data team, a central data platform, data assets, data lake. But in terms of, but what we learned through the years is that the most value comes from data scientists understanding the context of the problem they're trying to solve. So very early days, we would tag team. I would say I'll cover finance and maybe a little bit of product, so on. But as time went by, we realized the most value we can give is that by understanding the problem, we can apply this tool of data science, machine learning, data engineering better to the problems of the merchant. So that's why day-to-day sort of the teams are embedded within the product teams. They work closely with the product managers, UX researchers, development teams. But we also have the craft, and organizationally, we are one big org of data.
Okay, and let's talk about maybe we'll get into the process and all those things, but maybe the tools, the tech stack. What do data scientists work on in the sort of day to day?
For sure. So as I joined, we were actually going through this changing of our data platform, which is funny because when they hired me, they said you can join now or you can join in 3 months when we have rebuilt our data warehouse. Yeah, that took 2 years, and I'm glad I joined at the time I joined. So we basically moved from using Vertica to building a ETL tool in-house using Spark and Python. And then right now, as of last year, we've been in GCS, Google Cloud. So, and then in terms of sort of query layer, we use things like Presto heavily, a little bit of Redshift, and then like different visualization tools.
That's because initially you were a big Ruby shop, right? Because that was Toby's professional background.
So Shopify, the application, is still Ruby on Rails. And actually the first version of ETL tooling that was built in-house was Ruby. But I think we made this decision of moving to Python around 2013, 2014, because we thought it's the language that most of the community and people we want to hire are using. So it was sort of like a forward-looking definitely forward-looking because in 2013, 14...
Yeah, so Spark and Python a little more, but like Spark was not
very
not
early
obvious,
days,
right?
and it wasn't really good at joins. So for a data warehouse, picking a technology that is not good at joins, there was a lot of learnings for sure there.
And what else? People work in, live in Jupyter notebooks or...
Okay, so I can go in a bit in that. So one thing we invested heavily in through process of IPO and going forward is that we realized as a company, it's amazing that we have all of this data. It's amazing that we have this open data policy where everyone can access data and answer their questions. But the moment the consistency goes away across different answers for the same question, the trust in data goes away. So we invested a lot in making sure we have very solid data pipelines for like building our ETL using Spark Python in-house language, and then so it depends on the kind of analysis. Like we have this we use mode analytics for like SQL. We do Jupyter notebooks for ad hoc or one-off analysis, but for machine learning and things like that, we sort of run them through the same parts of our ETL platform that uses Spark. And yeah, so we do like streaming, things like that, but within the platform we have.
Okay, great. So let's talk about some of the use cases. So I think you started initially, the first project was Shopify Capital. Is that correct?
Yes, yeah. So Shopify Capital is a product where we give cash to our merchants to help them grow their business. Now, what's interesting is that we only take money back when the merchant has made money. Like we want to put our success in the success of the merchant, and we like committed to it to the point of implementation. So we said, okay, when we started, we said we want to be able to say with a high probability how much money a merchant is going to make, but in what time frame as well. Because you want to be able to, you want to have some sense of probability of how likely it is to get that money back. And I think it's also a good experience for people that are trying to bring like machine learning in different organizations. So we had just gone through IPO. It was like we had clean data. Basically, the importance of that is that our feature engineering and cleaning of the data was in place. And we said, okay, let's try machine learning for this. But in the beginning, we used machine learning for only a portion of the portfolio. And we said, okay, for a simple part of this, we're going to use models that are explainable, that we can sit with the product manager, the person from treasury, and walk them through, like, okay, these are the features. This is the feature importance. This is the measure of risk that we are taking. And then after the first iterations, they became comfortable. So luckily, and it's a good milestone for the team that as of last 2 years, Shopify Capital is entirely machine learning driven. So it means like we are able to project the sales of the merchant with a good accuracy and the velocity of the sales as well. But like I think it's good for people to know, from the outside, you say, oh yeah, it's completely machine learning driven, but it was, I think, successful because for the first 6 months or 9 months, we sat with them every month and said, okay, this is why this offer is going out. This is why we're giving this money, so that we gain the trust of the audience of the models.
Great. And the next project was NType Fraud?
Yes. So then after that, so I think it was like this pivotal moment in Shopify where before that we were using data for making data-informed decisions about what to build, where to invest, all of those things. But I think that was a moment where we said, okay, we can actually use data to create experiences. So Capital was the first one. Then we said, okay, the experience of fraud for a small merchant or a big one is not a pleasant one because the merchant would lose the product, they would lose the money, and they would lose the trust in the buyers. And if you think of like a small merchant just starting, that can hit them in their cash flow pretty hard. For large merchants also, they don't want to like go and review thousands of orders, and they don't necessarily have the experience. So okay, that's a problem that's worth it for us to solve at scale. So we started actually, again, very basic because for this problem especially, it wasn't just the model that was important. We had to be able to run this analysis in real time because as soon as the order comes through, you want to be able to say how likely it is to be fraudulent so that the merchant can decide to fulfill it or not, right? Because if it's fraudulent, you don't want to send them the goods. So it meant that it has to be scalable to the scale of checkout. So at peak time, we had over 600,000 checkouts going through, and we didn't want to say, okay, now we're using machine learning, so let us slow down the platform or take away the trust of the merchants. Like the users don't care what you use; they just want a product that's resilient. So the first experience of building that, actually, we used like very simple logistic regression with a bunch of features we had, because the first time you go from any rule-based or non-machine learning to machine learning actually is the time that you get the highest lift. So we focused on bringing this understanding, the sort of before and after machine learning, because machine learning by definition is going to have probabilistic element to it. So there are times where we would not have a reliable prediction. There would be times where the sort of state of the world and our features would change. And we spent a lot of time thinking about that parts of the problem. And in terms of architecture, we isolated it well that afterwards we could drop in different models. So then after, like, we changed the logistic regression very fast, but it allowed us to sort of understand the scale needs of the problem and be able to have good monitoring in place so that we can iterate faster on algorithms. one thing we did, which I think helped us in other projects as well, was that instead of focusing on, we have metrics around classification, all of the confusion matrices, but at the end of the day, like as I said, the user doesn't care about that. So we started focusing on product metrics, things around like what's the trust of merchant? How often do we tell them to cancel something and they actually listen to us? Or before shipping a new model, we go and say, okay, how's the experience of the merchant going to change as a result of that? Because people rely on us for doing this decision. So we spend a lot of time thinking through what happens before and after a machine learning model is deployed. And I think that allowed us to like bring other products to market faster.
And have you retired machine learning models because the experience turned out to not be as great?
We have not shipped models. So we have this like 2-week cycle where we put new features, we look at the lift, and we do a lot of backtesting to see. So backtesting is very common in finance, and you run the model basically saying like, what would have happened in production over the last 6 months if I had run this thing? And there has been time where we've seen, okay, this model is really good for a select slice of the merchants, but for everybody else, it's not going to make their experience better, or it's going to cause confusion. So we actually don't ship it. We don't bring it to merchants. We learn what we can learn and move on to bringing next set of features and models.
And you made all of this is super interesting. There was a point that I thought was particularly fascinating, which is that you when you have a rules-based system, you get most of the lift doing fairly simple things, if I understood correctly, and then you finish with machine learning. Have you how much of a plateau have you experienced with machine learning? So machine learning is pretty good at getting the probability right for the the first 60-70%, and then it gets super hard. Have you? And you guys almost by definition keep getting more and more data. So like, are you plateauing at some point?
I don't think we have hit the point of plateau on that problem, but I do see that our lifts become less and less. And I think that's just the nature of the problem. So in cases like fraud, because the fraud patterns change all the time, you always get new data. And we're really lucky we have visibility into back end of the stores and the front end of the stores of merchants. So we get a lot of data. But I do think that after that first sort of, the biggest jump is when we went from no machine learning to some machine learning. Yeah.
And Shopify Capital, the NType Fraud. Now you've built a whole portfolio of data science and machine learning driven products. What else have you guys built over the years? And also, how do you go about selecting the next thing and getting it through?
Maybe I start with how we go about first, because I think that's the key. Otherwise, it would look like a random selection of things. So the way we go about it is that we are always like product and merchant focused. So we say, okay, this is a product we are trying to, this is a problem we are trying to solve for merchants in this domain. Let's first understand the problem, like what are they trying to do or what the buyer is trying to do, learn a bit. And if we can, we would use the machine learning. So I always tell the team is that data is very powerful. Machine learning is very powerful, but at the end of the day, is a tool. Like if you use it properly, it's useful. If you just if you use your axe for everything, it's not going to be a good use case. So one of the things we realize is that we can help merchants a lot in setting up their store or knowing what's the next best action to take. So when they log into their Shopify store, in the admin, they see a bunch of like home cards that tells them do this or like market for this product or make this change in your theme. And those are all driven by machine learning. And we track it by thinking like, okay, how often do merchants actually do the things we tell them, rather than like, oh, we think this is a really cool algorithm to put out there. We have a marketing assistant or chatbot kit out of San Francisco. And then the focus is across Shopify, across all products that we have. How can we make them, even simplest products, how can we make them better? One of the things we did a while back is that we put this product classification. So merchants can add any kind of product they want. We don't ask merchants for data that we are not going to give a benefit to them right off the bat. So if for a merchant is not valuable to say what kind of product it is, we don't want to force them to like fill out all of this information for us. So we said, okay, if across the platform we can say what are the kinds of products, that unlocks things for everyone, right? It unlocks for people that are trying to buy shipping labels, people who are trying to market something. So we do a lot of those things underneath as well, just to make the experience of merchants better.
Mm-hmm. So what other products have you, just like a sample of other machine learning products.
products.
Yes.
So a lot of ranking and recommender systems in home feed that we have. We have a very large ecosystem in Shopify where we work with partners and app developers to build on top of Shopify. So we have app recommendation that matches merchants' needs with the next app that they can use. We do a bit of things around shipping. So it's really wide across different areas of commerce.
And maybe it's helpful to the audience to take a lot of what you said and putting it back into a framework. So I think you mentioned in some of your talks the Monica Rogati's pyramid. Do you want to explain what that is and then how that relates to Shopify's journey through to data science and machine learning?
For sure. So Monica Rogati, who used to work in, I think, Fitbit and Jawbone for years, she has this great pyramid of data science hierarchy of needs. And it starts with, first of all, you have to do a data acquisition. So you do eventing, you do data collection. Then once you have the data, you have to think about how are you going to move it from one location. So either from operational systems or API endpoints to your data lake. And then pipelines for that movement and how resilient they are. Once you have that, then you can have reports and dashboards to sort of look at what happened in the business and be able to explain them. Then on top of that, you can have things that are maybe closer to causal inference, where you do deeper statistical analysis. Then you can do A/B testing. And at the top of the pyramid is machine learning and AI. And I don't think they mean top as the best, but it's you have to go through this to be able to get to the top. And there has been times that even us, we've sort of jumped to the top in one of the areas, and you pay the technical debt that you did not do the work in the beginning. So in the beginning, when I joined Shopify, we were mostly trying to make sure we are collecting everything when we need it, because you're startup, you're moving fast, so data collection is not top of mind for all the engineers. And how to build the culture around the fact that that's important. Then we spent a lot of time rebuilding our data platform for pipelines and how we get data to be in one location and how to have consistent definitions across data, reports and dashboard. And then I think even from the early days, we had experimentation, which is a very interesting point. But over the last 3-4 years, we've had machine learning products in Shopify. But even when we go, it's kind of interesting. So we have new products all the time. And when we go to a new domain, the conversation we always have with the data team and with the product teams is that let's first focus on the lay of the land. Let's understand what's going on, collect the data for that, try to establish some sort of benchmark of what we are trying to achieve, and then go to machine learning. Because machine learning, by definition, brings some complexity to the domain. So the more you can sort of get rid of in the beginning by doing just the basic work, the more successful we're going to be in the long term.
All right, last couple of questions from me, and then I'll open it up to people. At a very practical level, the question on many people's mind: how do you recruit machine learning people?
I recruit machine learning people by not going after machine learning people. So it's a bit. Because so one thing we learned is that the people that are very successful in sort of product organizations are people that can fall in love with the domain and use machine learning as a tool that they use for solving problems. So we often look at people that have tried machine learning or even other aspects of data science for solving a problem, either in their personal life or in their last job. And then we go by that because we think what makes someone successful is that sense of curiosity about data and problem and having the technical chops to follow that through. So then we look at, as I said, we look at other fields. So we look at bioinformatics. Of course, I'm biased, but we also look at astrophysics. We look at economy a lot, actually. So we don't go after traditional computer science or maybe even machine learning training. We have people from those backgrounds. But I think because practicality of solutions are super important, we go for people that have an appreciation for that.
And just to double click on that point, so it sounds like you have a very multidisciplinary team. So bioengineering is the best feeder, are you saying? Because I've heard physicists in the past, mostly from people with a physics background.
Yes.
But that's the idea, is to build some people that come from math, some people that come from physics, and then how do they learn? Do you train them?
So I find like most fields like astrophysics, from all of these fields also these days have to do some element of coding. Like most of them come with knowing Python or R, and we do a very good onboarding, or we put a lot of effort in our onboarding. And I do think like with resources out there, like people come with a lot of experience already. I think most graduate degrees right now have coding courses. Like people of all fields have like GitHub profiles where they share their code and they learn from others. So I think that has been super successful for us.
Great. All right, last question from me. Predictions for the world of AI. 1, 2, 3, 5, whatever predictions. What are some of the interesting things happening? Whether they're big things or very practical things that are going to happen in the next 3 to 5 years?
My predictions are a bit hopeful, so I hope also things go that way. One of them is the research and work around sort of fair, accountable, transparent algorithms become more commonplace. Because I think users like ourselves are becoming more and more educated about their data and how these data products impact their life. So I really want that research to leave sort of just being academic and impact how we build products, how we collect data from our users and shape their experiences. The other one that I really want to see is a stop to sort of like human versus AI and human with AI. So I think, and I think as people talked about it before me, is that the more we can play to each other's strengths, the better. So I think like the more we can even build tools for combining human intelligence with like artificial intelligence, the more successful it would be. And the last one, I think there's a lot of hype and focus and good work in machine learning. But I do think if we take a step back and look at causal inference, we're going to actually solve a lot of problems with just that arm. So I hope over the next few years, like people invest in that, people learn from that. I think social sciences have solved so many of these problems in the context of the past, and that would also stop some of these things that we hear. Oh, this company hired a team of data scientists, but they were not able to answer any questions. Well, maybe you have to focus somewhere else. So these are my 3 hopes/predictions.
That's great. All right. Do we have questions?
I don't think so.
Okay, I'm very interested in terms of the process you go through in terms of bringing in a new model or replacing a model. Who's involved in the process? What sort of data do you bring? Is it standardized? Is it ad hoc? What's the sort of time frame?
So who's involved in general? Like there's always a product manager involved, there's data science people involved. And for each product, the set of metrics that we look at is specified. As I said, we go by product metrics. So for example, if it's a fraud product, we look at specific metrics that are different from what would you look at for like capital. So we focus on product metrics around the process. There's also like a longer talk that I can send to you, but in general, we do extensive testing before putting the new models in. We run them in shadow mode, which means like they do all the evaluation, but the results are logged to Kafka, and we see if the time to response, if the sort of distribution of predictions are different or not. So in that sense, we work very multidisciplinary. There's engineering people, there is UX, and there's product. And I think that has made it successful because it's not just about data, it's not just about the algorithm, but it's how is this going to act in wild world when it's released.
So Shopify is a marketplace, so you get access to a bunch of data for a bunch of different shops, but you also have AI or machine learning driven products that are serving shop owners based solely on their own data.
So we are not a marketplace. We are actually a platform allowing people to have their own brand. So actually all of our machine learning offerings that I was talking about are actually built for the individual use case of the merchant. So for example, if I have a small shop selling t-shirts, the machine learning model solve my problem. So it would tell me like where to advertise for my t-shirts. It builds a profile for me to give me a Shopify Capital offer or not. Yes.
Hi, so when you're training new hires to get more familiar with machine learning, do you tend to emphasize the theory behind the models, math behind them, and how they converge, or do you tend to focus how they work at a high level and then just the code that you write to actually implement them, or a little bit of both?
I would say a little bit of both, and it also depends on the complexity of the model. So when they're starting, we of course want them to understand the sort of basics of how classification would work, how clustering would like supervised, unsupervised, that. But many of these things are like openly available, say in scikit-learn or whatever. So we try to help them sort of understand the use case, understand what the outcome of the algorithm mean. And I don't think in many cases we go super deep. It really depends on the problem. So for example, if we are doing something with deep learning, then we really want them to understand because it's harder to understand what's going on inside the algorithm versus more simpler ones where people, it's easier to pick it up as well. So I think it's a mix really depending on the problem. But if it's someone fresh hire, we don't go super deep on the math of it.
Hi, towards the end, you mentioned that you're quite interested in seeing what's going to happen in causal inference, and I'm just interested if you could provide any colors to areas or use cases that you think they could be useful for at Shopify, and as a sort of secondary question, if there's any existing tools or techniques out there that you wanted to highlight.
For sure. So I think like one of the questions that come up in all the companies is that we released this product. Did it have an impact? Like we released this new like payments product in a new country. Did it impact conversion or not? And we don't want to necessarily hold out a bunch of the population. You can't always do A/B testing, or it might not be possible. So how can you use methods from economics like diff, simple things, to go back and say we think with a high probability there was impact? So we use that for answering questions that help us guide our product roadmap, how we are doing as a company. And I think that's sort of a neglected part of data science. Everyone talks about like machine learning and building all of these data products, but I think lots of the impact, lots of the trust and usage of data actually comes from being able to answer to sort of like simple but not easy to answer questions. So in Shopify, we use that also in our, we do that for our like deeper analysis that we do, and our product managers depend on this kind of analysis. There's a lot of good work being done. I think there's a few books being published. There's packages in Python being written. I think there's a lot of work in like survival analysis and things like that. Lifetimes coming out from Canada actually used to work at Shopify. So I think the community is also doing that. It's not just us thinking it's cool. And I would love to see more and more of that.
I guess a little bit to this point, like one last question from me. Like, what's the most exciting thing, in, like new thing in machine learning and AI, like new framework or tool, or like anything you're excited about and like learning about? Or isn't there anything?
No, there's many things.
No, because there's so much on like archive, like so many papers and all those things. But like, is there something that like you at a practical level, like with a 200-person team at your disposal, is like, okay, this looks interesting, like something we should experiment with?
I think the BERT paper that came out from Microsoft was really interesting. Another thing that has come up from Facebook, which is this like package profit where they use for forecasting. I think it's not necessarily the technology behind it that's like interesting, but it's how it has made things that were difficult, that were at the disposal of few, at the disposal of many. So for example, we use profit for time series forecasting all the time in Shopify, and it has changed the way teams work from having people in operations monitor metrics and see what changed to this is an anomaly. Now we would look at it. So I think for me, practically, I'm interested in things that can sort of like remove a pain point and help you move beyond sort of the toil that day-to-day you have to do. So in that sense, we are lucky because the different algorithms that come out, they each unlock some of these things.
All right, on that note, thank you so much. This was terrific. Thank you.
Thank you so much. Yeah.